Hooke's law. The extension of a spring is directly proportional to the force applied, but only up to a certain point. Now you can clearly see in the first region here up to around here, it's a straight line. So that is what we call the limit of proportionality here. And after that it starts to bend. And in this first region, the spring is elastic. So the idea is, if the spring is elastic, if you remove the force, it will go back to the original shape. So beyond that, the behavior becomes plastic. If you exert a force, the spring gets longer, and we call this extra length the extension. The units are very important. Force is measured in newtons, extension is measured in meters, and this K here we call the spring constant, and it's measured in newtons per meter. The area under the graph gives you elastic potential energy, half Fx. There is a second variation of this formula, because we know this F is the same as Kx from before, right? F equals Kx. Now if I substitute Kx for this F, I get another version. Elastic potential energy is equal to half Kx, and this x at the end, obviously that's half Kx squared. Here's a typical GCSE style exam question. Pause the video and give it a try. EPE. Now we have half Fx and half Kx squared. I know K and X. The formula with K and X is this one. So let's use that. EPE is equal to half times K is 40 multiplied by X is 1.5 square. Explain what would happen to EPE if the spring constant doubled. So the spring constant is not 40, it's 80 now. That's okay. But the extension stayed the same, so the extension is still 1.5. Let's use the same formula one more time. EP equals half Kx squared. So this time you get 90 joules. So the command word here is explain, and we can see previously it was 45, now it's become 90. So you can explain that elastic potential energy doubles.